Looking at quadratics, there's two different forms in terms of quadratic equations. We have standard form and we have vertex form. Today we're going to be looking at standard form. Now, standard form of quadratics is in the form of y equals ax squared plus bx plus c, where a, b, and c are different coefficients. A cannot equal 0. If a were to equal 0, you wouldn't have an x squared term, therefore you would not have a quadratic. With that being said, looking at standard form versus vertex form uses an a value as well, which happens to be the same in standard form. So that a is going to determine whether our quadratic is facing upward or downward, as well as how far our branches are stretched or shrunk. So with that being said, there are ways that you can find the vertex of standard form. The vertex, the x value, or the h, remember the vertex is in the form of h comma k, the h can be found using negative b over 2a. The k can be found by plugging in the h value into our equation. Shouldn't say plugging in, but substituting rather. So for instance, let's say that I have y equals x squared minus 8x plus 5. Okay, our goal is to figure out what is the vertex. Where is the vertex located? Okay, so with that being said, what I always like to do is I always like to list out, okay, what's my a value, what's my b, and what's my c. So notice that 8 became negative because of the sign in front of it. We have that negative 8. So with my vertex here, I am going to substitute in my values to this formula. So I have negative 8 over 2 times 1, which is going to give me positive 8 over 2, which is 4. I have just figured out the h value for my vertex. Now I need to substitute in order to find my k value. So I'm going to have 4 squared minus 8 times 4 plus 5, and that's going to give me my k value. So 4 squared gives me 16. 16 minus 32 gives me negative 16. And then plus 5 is going to get me my negative 11. So my vertex is located at 4, negative 11. The axis of symmetry, remember it's just whatever our h value is. Our axis of symmetry is at x equals 4. So now I can use that information to figure out where does my parabola lie. So if I were to ask you, how do you graph this off of this? So what I would do, how to graph from standard form. All right, so we already have our vertex. So what I'm going to do is I'm going to kind of create a chart. So I know my vertex is at 4, negative 11. So what I'm going to do is I'm going to pick a value to the left, one value to the left of x. So to the left would give me 3. And then I'm going to pick one value to the right of x. So 5. Now, you could do the same thing if I did like 2 values to the left of the vertex, then I'm going to pick 2 values to the right of that same vertex. So kind of like how we figured out the k value for the vertex, we're going to do the same concept on that table using the 3 and the 5. So I'm going to substitute those values in in order to calculate where they're actually at. So if I'm looking at this, I'm going to have 9 minus 24 plus 5, which is going to give me negative 10. I'm then going to take that 5 value and do the same exact thing. And I now have 3 points that I could then graph those 3 coordinates in order to find that U shape. To get a better U shape, you really should probably pick 5 points so you can see how that curve is going to match up. So I would pick, again, 2 points then that are 2 to the left of the vertex and 2 to the right of the vertex. So everything is based off of that vertex. Last but not least is trying to write an equation of a parabola given 3 points. So for instance, let's say that I have points at 2, negative 12, negative 1, negative 15, and at negative 4, negative 90. So when looking at this, this kind of looks a little scary at first, but it's really not that bad. I say it's not that bad because you set this up in matrix form. So for instance, this 2, negative 12, what we're going to do is we already know everything's in the form of ax squared plus bx plus c. So I'm going to have a times, or sorry, no, it works. A 2 squared plus 2b plus c is going to equal negative 12. Okay, so looking at this, this is really 4a plus 2b plus c equals negative 12. Okay, not that bad. Now let's work with that next point. I have negative 1, negative 15. So same thing, I'm just setting it up in that ax squared plus bx plus c format in order to kind of get some equations here. So I'm going to have 1a plus, well, minus negative 1b plus c equals negative 15. And last but not least, my third point. So I have a times negative 4 squared minus 4 times b plus c equals negative 90. So I have 16a minus 4b plus c equals negative 90. So you're probably sitting here thinking, all right, Mrs. Fish, you got 3 equations and you still have 3 variables. You're right, I do. But this right here, if I look at my 3 equations that I found, is really a system of equations that we can use our matrices for. So I have 4, 2, 1. I'm going to just do this off to the side, that negative 12. 1, negative 1, 1, negative 15. 16, negative 4, 1, negative 90. So using matrix, using my matrices here, I have a system of equations that I can now solve, which is going to give me my A, B, and C, which is going to give me my equation. So I could go to my desmos.com/matrix in order to calculate this and to get my A, B, and C. So when I plug this in, I get my A value to be negative 4, my B value to be 5, and my C value to be negative 6. So I can now write my equation. Y equals negative 4 x squared plus 5x minus 6. So using previous material with our matrices in order to figure out our equation. So this is quadratics in standard form. Again, it's y equals ax squared plus bx plus c. We can find our vertex without having to switch it into standard or without having to switch it into vertex form. and we can find an equation based on 3 different points.